What's up, guys? It's Mr. Wicklehouse, and today we are solving systems of equations using matrices. This is going to make your life so much easier in the future when you start solving systems, because you can just punch these things into your calculator. Alright, so that being said, let's figure out how to write a system as a matrix. Alright, so they gave us this system, and of course it's going to go out of focus on us because, you know, that's just what it does. There we go. So we've got this system here. I see that this has 3 variables in it, which is the largest number of variables that I have. So I'm going to have to make a 3 by 3 matrix. Okay? So let's start out by writing matrix A, and matrix A is going to be everything to the left of the equal sign. So matrix A is going to be a 3 by 3 matrix, and it's only going to include the things on the left hand side of the system or of the equal signs. Okay? So this first one's pretty simple. It's got the 3 variables and it's got the 3 numbers in front of the 3 variables. So that's going to be my elements in my matrix. This is element 1. It's going to be 2. Element 2 is going to be 3. Element 3 is going to be -1. So there we go. We've got our first row of our matrix made. So the top 3 elements are going to be just the top 3 numbers there of your system. Okay. Now I look at this next equation and I see it's got 4y plus 3z, but I don't have any x. Well, if I don't have anything, what number goes along with nothing? 0. So for my x coefficient, or my leading coefficient on my x value for this equation in my second row, is going to be 0. So that's going to be element 4 in this matrix. Okay, then I just list the other 2 coefficients on these other 2 variables. So then I've got 4 and 3. Alright, so my second row is 0, 4, 3. Now let's do the last row. Alright, so I see I've got an 8x, but I don't have a y and a z. Similar to what we did up here when we didn't have the x, we put a 0 in. We're going to put 0 in for the y and the z. So the coefficient on the x is going to be 8. And then for the y and the z, I'm just going to put a couple zeros. Okay? Alright, so that's the matrix that goes along with everything to the left of my equal sign. Now I have to deal with the stuff to the right of the equal sign, and I'm just going to make another matrix, and I'm going to call that matrix B. And this is going to be just 3 rows, but since there's only the 1 number over here, it's going to be 1 column. So there we go. It's going to be a littler one. There we go. So this is going to be 5, 1, and 11. Okay. So there's the numbers. Now let's write this as an equation so we can start thinking about solving it. Okay. So when I write these, I'm going to put matrix A first. I'm going to have it just like this: 2, 3, -1, 0, 4, 3, 8, 0, 0. Okay. I'm going to do something that's kind of a little weird, but not really. It's just a little bit different because I have to name each one of these rows as the variables that I have in my equation. So x, y, and z. Okay. So then if I was going to redistribute this and stuff, then I could do that and get this system back. Okay. Alright, and then that's going to be equal to matrix B, which is 5, 1, and 11. Okay, so now I've taken my system, put them into two different matrices, and then rewritten that system as a matrix equation. Okay, alright, so let's solve this thing. Alright, so solving the system with the matrix, we're going to use our calculator and the inverse of the matrix to find our solution. Okay, so remember, this is matrix A, this is matrix B, and this is just the variable matrix. I'm not really even going to think about that too much when I'm doing this. Let me move this equal sign over just a little bit. Okay. Now I haven't talked about this at any point in any of the videos up to this point, but I want to talk to you a little bit about multiplication with matrices. Multiplication with matrices is different than regular multiplication. So regular multiplication, I could say something like 3 times 2 is equal to 6. And from the same standpoint, I could say 2 times 3 is equal to 6. That works out that way. Well, with matrices, it's not as simple as this because of the way matrix multiplication is done. So I have to worry about the order that I do things in. Okay. So if I multiply on the left-hand side of this, the inverse, then I have to multiply on the left-hand side of this B, the inverse. I couldn't put it over here on this side because it'll give me a different answer. So just remember with matrices that if you multiply something on one side and then you go to the other side, make sure you multiply on the same side as you did on this one. So what I'm going to do here to solve this is I'm going to multiply by A inverse there, and then I'm going to multiply by A inverse here. If I were to multiply by A inverse over here, then it would give me a completely different answer than multiplying by A inverse over here. Okay. In any case, this is going to give me the solution to my system. Okay. It's going to give me the solution for this X, Y, and Z is going to be equal to whatever this is. So let's put this in our calculator, make our lives easier on ourselves. I'm going to enter this in, go over to edit. We should be getting pretty good at this by now. This is a 3 by 3 matrix, and this is 2, 3, negative 1, 0, 4, 3, 8, 0, 0. Okay, so there's that one. Quit that, go back into matrix, go over to edit, go to matrix B. This is going to be a 3 by 1, and this is going to be 5, 1, and 11. Alright. Well, now comes the easy part. I've got all that stuff entered in. I'm going to go to my matrix, and I'm going to pick matrix A, hit the inverse, then I'm going to go back into my matrix, go to matrix B, and then hit enter. There we go. Now this one didn't come out real nice and pretty because I made this up off the top of my head. Okay. If you don't like the decimals, you can go in here and do fraction, and it'll change everything to fractions for you. Okay. So that being said, we can see our solution is for the X is 11 over 8. For the Y is 31 over 52, and for the Z is negative 6 over 13. And that, my friends, is how we solve a system with a matrix. This will work for the word problems after you set up the matrices with the word problems. It works for any kind of system at all. The bigger these matrices get, the bigger, works for 4 variable systems, 10 variable systems, as many variables as you can think of. You can use these matrices to solve them really easy just by doing the inverse times whatever the solution is to the thing. So, all right, that's all I got for you today, and I'll talk to you later. See ya.